Incorrect values in your most important metrics on your dashboards, like calculating revenue, EBITDA, stock counts, multiplied records in result set for your SQL query results when doing join operations. This is just the top of the icebergs when dealing with one particular problem in SQL or in general in data world, which is duplicates. And this is what we are going to talk about today: how to handle duplicates, how to deal with them, how to find them, what exactly is duplicate in data. Welcome back, friends, and let's get to the topic right now. So before we start, this is just the sample table that we are going to work with today, but the problem remains the same. What exactly is the duplicate? So here I'm just creating a simple products table. As you can see, this is kind of important that I don't have here like any sort of ID column nor any sort of unique key constraint that will tell me that particular record is unique. We are going to get to this one later in the video, but the table itself has three simple columns: product name, product category, and description, right? Let me just add 3 records. And as you can see up front, 2 records in the result set are basically the same records, meaning that all of the values are exactly the same. Product name is exactly the same, it is product 1. Product category, it's exactly the same, toys, and the product description, it's exactly the same, it's toy soldier. And in that case, this is my definition of duplicate. Of course, you can check different definitions in your dictionaries, ChatGPTs, etc., right? But from my perspective, duplicating data, it's basically the same values across all of the columns in the results set when talking about the results in your data. Why is that important? Because right now I will show you an example when presenting the result set, the data might be the same, but when we will check actually the data itself in the database in a specific column, we might have missed in that particular case a modeling thing that someone has not presented in the SQL query. So let's get into this example. What we are going to do now, we are actually going to add one single column which is actively sold, and this will be just Boolean flag that is not null and the default is true. Now, so what I'm going to do now is actually I'm going to add another product with the same name, product 1, the same category, toys, slightly different description, and actively sold set to false. So right now our data set will look like this. We have 4 products, 3 of them are named product 1, and actually you can see that all of the flags are set to true for first 3 products added to our table, but the last one is set to false. Now, when we are seeing whole result set, we can obviously say, okay guys, this is the first 2 records are actually duplicates. This one might be potentially duplicate, but actually when looking at all of the columns, it's not duplicate because it has different description, it has different actively sold flag, right? But how this will change if, let's say, we are going to, for instance, present just this information, right? In this particular example, we don't have information about the actively sold column. So we are missing one kind of crucial, right, column information from our data model, which is basically information on whether this particular product is actively sold or not. And maybe this is a red flag for us that we should add this particular column into our where clause to filter out only the products that are actively sold, or maybe when we are looking for those that we are not actively sold, so looking only for those. Another example, let's remove even product description. So in this case, it will be even more obvious that, okay, so actually we have 3 duplicates in our data set, because record 1, 2, and the 4th one are actually the same, right? But again, 4th one is actually different. It has different description, it has different actively sold flag, but depending on how you will structure your SQL query, how you will present your data at the end of the day, what will be the results, the result columns, the definition of a duplicate, or actually the data presented as a duplicate, will be different. But what I want to say here is that it's important to understand the data model behind the scenes, because something that might be at the beginning actually the duplicate, it's not duplicate at the end of the day. So when we are going to next go through the solutions, how to fix the duplicates, how to remove the duplicates, always keep in mind to check first and understand the data model, because for instance, distinct operation might not be needed when, for instance, just adding actively solved flag to the where clause would be the solution and would be far better performance in terms of performance than doing distinct operations. But before we will jump into this topic, how actually we are going to find the duplicates. So one kind of pretty obvious thing to do would be to calculate the counts, right? So we know how many records we have in the database, and we can, for instance, say if we are looking for duplicates based on the product name, we can do the count with distinct operation based on this product name column. In this case, we are going to get results that there are 2 actually uniquely named products, while there are 4 different records in the database. Okay, so this is an information for us that we have 2 unique product names, but 4 records are assigned to those unique product names. We are not getting here any information about the split. So for instance, that there is 2 products with the name ABC and 2 products with the name CDE, right? But we already have something that we can work further with, right? How to get more information, especially when we want to check not a single column as something to check the uniqueness and values for the distinct values and duplicates, but actually we want to check whole record, so all of the columns. In this case, we might want to calculate the checksum or hash values for the whole record. If we don't have such column in our table, we can calculate it on the fly, which is costly operation, of course, but in certain cases, it's definitely helpful. So what we are doing here, right, is basically we are calculating MD5 hash of the record. This basically syntax means that I'm going to take whole record from the products table and cast it. This is basically cast operation in PostgreSQL. It could be rewrite to cast as text. And we're going to cast whole record as a text and calculate the hash of it, right? So then we are grouping by the hash itself and calculating the count of the records. So we can see right now even more information that there are actually 3 different records and 1 particular record is duplicated. So 1 record has exactly the same informations in all of the columns because the value of the count is 2 in that case, right? Now, let's say we want to work more on this first example with distinct product name, right? So we do want to check duplicated product names, but we want to show actually the product names themselves and the counts for those. In that case, simple group by product name count operation, group by product name, and having here. So filtering once the aggregation is done. Having count greater than 1 will present us with the information about the product name that has actually more than 1 record in the products table. In our case, this is product 1. Another option, which is also available for you in your SQL toolkit, is using Windows functions. So this video is not about Windows functions themselves, so I'm not going to get into much of the details here, but in some certain conditions, I'm going to show you those conditions later in the video, is pretty useful to have them in your toolkit. So what we are doing here is actually basically kind of similar information that we are doing here with group by and having, but we are actually doing that in a window function in the select statement itself. So what we are doing here, from the products table, we are getting product name and we are calculating the count. So we are using the aggregate function over, and we are naming the partition that we want to calculate the count. So basically we are saying that get me all of the count for the product name specifically, in the product name group specifically. And then having those counts, we are filtering those where the count is greater than 1. The result here, we are going to have not like a single record like this one, product name, product 1 and the count 3, but actually we are going to get 3 records representing the records in the products tables, which will be useful, especially when we will want to delete them from our table later on. Now, the same can be achieved with not using the count, but actually with using row number. It's actually the same operation, meaning that it will yield the same result. The only difference here is that I'm not using where count is greater than 1, or in our case it would be row number greater than 1, but I'm actually saying, okay, so for the product names, right, that I'm doing the partition by on, and then calculating the row number, I want to check which exact product has potential duplicates. So when I will do here row number equals 2, this information is basically information for me that there is at least one record in the products table that has the product name exactly the same that another product in the products table. Obviously, in our case, if I will do here the 3, it will also work, but with 2, you definitely have the confirmation that there is a duplicate, meaning that there is another record in your products table with exactly the same name. Now, we know that we have duplicates in our data, in our products table, depending how we want to actually name the duplicate, define the duplicate, whether this is the same exact information on the product name, or this is exactly the same record, meaning that all of the columns are the same. We might want to remove them, right? And now removing can be actually done in 2 different ways. First one is removing in the result set. So we don't want to delete the duplicate from the table, which we'll get back in a couple of seconds, but actually we just want to remove it from the result set itself. It's up to you as a developer to get the idea which one you prefer to use. From my perspective, it's always great to understand why I have exactly the same information in my result set, and based on that, make a decision whether to remove them from the table or remove them from the query result. But in this case, I'm going to show you both. So distinct, probably you are already familiar with this operation. So distinct gives you a possibility to remove exactly the same records across the columns that you are mentioning in the SQL query. So here we are doing basically from products table, we are listing 3 columns: product name, product category, and product description, right? And now when we are going to execute this select statement, we are going to get not 4 records as previously, but we are actually going to get 3 records. So as you can see, this product 1 toy soldier was removed. One of the records was removed, right? So this is kind of working as we expected. Now, if we are going to remove product description, our result set will be further narrowed. So we are not going to get another toys description that we've added at the beginning with this actively sold flag set to false. Right now our result set is basically 2 records, right? The same thing we can actually get using window function as presented before. So product name, product category, product description, and we are saying that we want to calculate the window function, which in our case is row number, over partition by product name, and we want to select only the first row numbers. So only the records that the row number is equal to 1. In that case, our result set will be basically product 1, toy soldier. You can see that there is 2 records, not 3, as example here with the distinct. Why? Because distinct here is checking all of the columns named, all of the columns that you are specifying in the query, while the window function is actually doing partition by a single column, which is product name here in this case. That's why in the result set of this select statement, we are just getting 2 records as we would do with this select distinct, right? This is kind of important. We are not specifying here order by. So this, for instance, could be product 1, toy soldier, those with actively sold flag, but actually in our case, this is basically taking the first inserted record from the result set. Now, this is how you could work with removing duplicates from your result set on the fly when doing the select statement, right? But in majority of the cases, especially when you are actively adding data to your tables, to your transactional tables, it might occur that you might get the duplicates there if not properly managed by, for instance, some unique constraints or any other checks that you are doing on the tables, right? So in that case, you might want to remove the duplicates from the tables themselves. Now, how to do it? Obviously with delete operation, but the problem gets tricky, especially in our case, when we don't have some sort of identifier of the record, right? We don't have information about the ID because our table is just the product name, category, and description, right? So it's getting kind of difficult how to properly remove just, for instance, single one record, right? But let's start with something far more simpler. Let's say, let me switch the transaction context because I don't want to keep adding, reinserting the records. So let's say that, for instance, in our case, we just want to delete all of the records from the products tables where the product name column is potentially duplicated. What does it mean? It means that if, for instance, product 1 is in the products table more than once, we are going to remove all of the product 1 records from the products table. And in our case, we can do it with using window function to get basically information which product name has potential duplicates, so has basically duplicates on a product name column. And this, as you've previously seen, will give us product 1 in the product name, right? And then we are executing delete statement, helping ourselves with this common table expression to get the dupes with basically an exist filter. So we are doing delete from products where exists from duplicates, duplicated product name, and p product name. So basically we are matching on the product name. So in this case, all of the records from the products tables with the name product 1 will be deleted. Let's execute it, right? And let's check the select star from products. As you can see, we are left with only a record with product name equals to product 2. So this is an option, right? Probably not the best one because we might want to leave at least one record with the product name named as product 1. In that case, we want to delete all but one. Now, how to do it? Again, we can help ourselves with basically the window function in that case, in our case, because again, we don't have any sort of identifier that we could easily use in case of deleting. So first, checking all of the records, getting the IDs, and then helping ourselves with the IDs. So in our case, we are going to use the window function, where first we are actually calculating the row number based on the product name, again, product name, right? Then we are matching this record from this subquery using the calculated checksum of the record. So here we are basically matching all of the records from the products table in the subquery with the product records from the top delete table. And then we are saying, okay, do this when exists at least a record when the row number is greater than 1, right? So what this query will actually do behind the scenes. So in case of the product 1, it will actually mark product 1, one of the records as row number 1, second record as number 2, and the third record as row number 3, right? And here we are saying, let's delete all of the records with product name that is duplicated where the row number is greater than 1. So all of the records where the row number will give results like 2, 3, etc., right? Let's check if this will work. As you can see, product 2 was spared, as in the previous example, but here also we are getting product 1 back with the product category toys and toy soldier old version retired. So we are not necessarily have the power over which actually record will be spared, unless we would want to add here like order by, then we have more control over which exact record will be spared in terms of insertion, for instance, like created date we might have in our product table or updated that. So in that case, it would be a bit different. I'm here just now focusing on showing you the possible solutions. Now, in some of the database, Oracle or PostgreSQL in my case, because I'm using it to show you this example, you have columns specific for the database actually that are helping you in some ways to show you not really show you, but show the database, like let's say it's kind of an ID without explicitly defining ID in the column. This column is actually called ctit, and you can, to any table, you can basically do always in PostgreSQL ctit, and you will get the value for this particular record. So even though we don't have an identifier in the products tables in the PostgreSQL, we can leverage this ctid column to basically remove the duplicates as well. So here, as you can see, we are just getting the row number, again, window function, over partition by product name. And with using ctid, we are listing the ctid here, and then just simply using this common table expression in the using clause of delete statement. So using dupes, where ctid is equal ctid from the products table, but the row number calculated must be greater than 1. So basically the same operation that we've done here, but helping ourselves with the ctid, which, well, makes query a bit, let's say, maybe more readable for the user, right? Let's check if the result set would be the same. Again, we are left with 2 records, and in this case, as you can see, not the last one was spared for the product one, last inserted one, but actually the first inserted one was saved here in this particular example. Now, so this is example of how to deal with duplicates when doing select, and how to deal with duplicates completely removing them with delete. But you can also deal with them in a slightly different manner. So let's say that in our case specifically, we have this situation where the product one is duplicated with the same description, for instance, or in this case with different description. So let's just assume that we would want to show all of the records from the table, but actually we want to combine the information from the description, for instance, or from the product category. In that case, we can basically leverage some of the SQL functions that our database engine gives us. In my case, this would be string aggregation. So I'm doing here from products table, I want to list the product name, and I'm doing here the string aggregation based on product description. And you can see here that for one example, I'm doing distinct, and for the other one, I'm not showing you the distinct value. What would be the result set? Basically, we are going to get 2 records, not 4, so that's good. Only the product 1 and product 2. But in case of using string aggregation without the distinct, I'm going to get duplicates when merging the product description. So you can see toy soldier, then toy soldier again, and then toy soldier odd version retyped. So basically all of the records for product 1 were merged into one description divided by the slash, but in this case without removing the duplicated description. And in this case, with the distinct on, the same description will be removed. So the toy soldier that is actually in 2 different products will be removed, and only one toy soldier will be left. And the second one is different value, so it will stay in the table, right? So this is how you can deal differently with the duplicates in your data, especially when the data model tells you that it's not really a duplicate, or potentially might not be a duplicate, but you want to present this data in your output. So you can, for instance, show as an analyst or as a report builder, or as in general data engineer, person working with the data, that you want to explicitly show that, okay, here guys, we have the same information for the product one, so we have this record, but actually the values are slightly different. So this might be an opportunity for you to get some knowledge about this information. In our case, this is a simplistic example, but I can imagine tables with hundreds of columns that potentially some of the columns might have a slightly different information were, for instance, integrated from different various data sources, etc. And we don't really want to remove them up front, so delete them from the table, right? Nor remove them as from the result set as distinct or raw number, but we just want to show also this additional value, but grouping the records, so not causing the records to multiply in the result set. Now, one more alternative when it comes to using PostgreSQL is that PostgreSQL gives you a bonus, let's say. So it gives you a distinct on operation. So again, we have our 4 records in the database, right? And normally previously we were using window function, we were doing distinct, right? But what we had a problem with distinct was that doing distinct on 3 columns like this one, product name, product category, and description, would basically remove the duplicate when all of the 3 columns have the same information in various records, right? But let's say we want to do the same as we've been doing with window functions. So we've been partitioning by product name, but using the distinct operator. So in this case, PostgreSQL gives us this flexibility with distinct on. What is happening behind the scenes? You can imagine that the same exact thing that is happening here with the raw number. So first, the distinct operation is actually doing the partition based on the product name, and then removing the values with the same product name. Actually, here the sorting is needed. So some way the query engine needs to sort the data to know that it's the same information. But using this operation, although a bit costly, gives you a possibility to present like 3 or more different columns and do the distinct operation on 1 or more of them, right? So here we are removing the same values on the product name, but actually we are presenting 3 different columns. So this can be useful in some cases when especially you don't want to use window function or by any reasons, or you don't want to use just the distinct operator, or you don't want to delete the records from the database itself. So this is a nice addition in PostgreSQL world. I don't know about if the other databases have the same operator, haven't checked honestly, but if you do and know that there is similar functionality in your database, leave the comment down below. I would be happy to check it and add it to the blog post that's basically covering the same topic. So just to sum it all up, right, guys? You have right now the knowledge how to deal with the duplicates, what the duplicate actually is, how to find it, how to remove it from the select statement, so the result query itself, how to remove it from the table itself. What is also most important for me is that when you will be faced with the duplicates, when you will be faced with multiplied records across your data result set, think about whether there can be like a data model hidden behind the scenes that gives you an information, for instance, that it's actually not a duplicate, but a record that we can deal with somehow, like in our case with this actively sold flag example. If that's the case, that's awesome, because you can filter out this information sooner rather than doing expensive distinct or expensive window function at the end of the result itself, right? So it's kind of really important to check your data model, know how the data are structured in your table, and after that, do all of the needed operation for you to give the proper results, obviously. But please don't start with distinct, don't start with doing the window functions. First check the database, check the tables, what's in there, what might be causing the problem, and then fix it. Thank you for today. See you next time. Bye bye.